Hello again. This lesson is called the ice cube investigation. During this lesson, students will conduct an investigation to observe and then model the interaction between two different colored ice cubes and some liquid water that's added to it. Now, before this lesson takes place, it's important that you prepare the materials the day before by creating some red and blue ice cubes. While everyone knows how to make ice cubes fairly simply, my recommendation is to add just a little bit of the blue and the red dye to two large containers and swish them around before adding them to our water pans, our cube pans, excuse me. Right. You'll want to make sure that you have enough for the number of students or groups that you plan to have. So if you're going to do this investigation in groups of 3 or 4, likely one ice cube tray is enough. But if you are hoping to do this investigation in pairs, you may need 2 pans of ice cubes to have enough for all of your students. You'll probably also want to do this over a sink. I find that it helps to add a little more red than blue dye to your ice cubes as well to create a little more dramatic color mixing effects in the after observation when we add all the matter together. Once you have your ice cubes ready, you can perform the investigation with your students. In front of me we have the before setup for this combination of matter that we are going to observe. You're going to hand out a blue ice cube and a red ice cube to each group, whether it be pairs, groups of 3s or 4s. And you're going to have students either take a picture or document very quickly what this looks like before you add the liquid water to the tray. Now, one thing that I do recommend is that you have students begin modeling the before matter as this melting process is going on. Again, we're not giving them the word melting, but they kind of know what's going to happen when they start adding this water. I also recommend you find as warm water as possible to help speed up the process and get to something that is readily observable and can be modeled in some way on their after photos, after pictures. So I'm going to add this water. Again, this will take several minutes, especially as the liquid water will cool quickly and may not cool the cubes down to a temperature where they can start melting. Right? So at this point, they can be working on their model, their before models, while they keep one eye to what is going on with the melting ice cubes. Right? One observation that will immediately become apparent to students is this slow diffusion of red and blue water out into the clear liquid. And this is a great data point for kids to observe and think about what is happening. Where are those red and blue water particles coming from? And how are they now behaving as compared to the way they were behaving when they were a part of the blue ice cube? We'll see over time that this red and blue will continue to diffuse further and further out into the tray. It's important to note that kids do not need to use the word diffuse. They may use any different kinds of phrases. Some are going to say it dissolves, some are going to say it melts. And this is some language that we're going to want to tease out by asking them to tell us more about what it is that they're sharing. Ultimately, we are going to zone in on this process as being a melting process, one where material that was previously solid becomes liquid without changing what it is actually made of. So, of course, ice cubes are solid water. When they melt, they become liquid water. When students turn to their notebook, they're presented with a large space for their model drawing and the prompt, how does your model support your observations before the matter is mixed? These observations should include that the ice cubes are colored, take their shape, are solids, and that maybe the water in the cup is clear, it is a liquid. Whatever they say, they should be able to reinforce in their model based on the particles or the way that they draw their particles. In my example here, I've created red and blue ice cubes with some tightly packed particles that are keeping shape. You'll notice that there are no lines around my particles. That is a choice that I've made because there are no real boxes or lines around actual solid or liquid materials. But if students do draw in lines, you can ask them about that as to whether or not that is something that actually exists in the world or just a way that they're showing some demonstration of, for example, yeah, this is my ice cube that they might label, or something to that effect. Right? In my before model here, I have 9 particles of red and blue ice cubes, and I have 35 liquid particles here in my cup of water. Again, the larger the particles they draw, the easier it's going to be to count and to justify when they're talking about whether or not there are more or fewer particles in the before and after models. Here in my after model, you see that I've removed all the particles from the cup, the liquid cup, and added them into our pan here. Other changes that you'll notice is that I've reduced the number of particles, of red and blue particles that were tightly connected, and taken those particles and spread them out amongst the now present black water particles. There are always many ways that our kids can improve or modify their models. One thing I did not do in the before model that I could have done was label specifically blue cube, red cube, water, liquid. I might even go so far as to do that here, liquid water, or add in once again those force arrows that are showing all these things moving around and such. Right? These are things that your students are going to choose to include to demonstrate their understanding of what is going on in this natural phenomena. Another thing kids might start doing is they might start, in your comment around those solid lines and what do they mean, they might start adding their own particles here to demonstrate that this is in fact a solid. They might even go so far to include that in their model. If so, great. As long as the student can justify it in their language and their explanation as to what they are drawing or seeing in their model, we want to encourage that. So that's only going to promote more discourse, more interesting conversations in your classroom around what students are sharing and why. In conclusion, the Ice Cube investigation is designed to continue to work students towards attaining the standard of using a model of matter made of particles too small to be seen to explain common phenomena, in this case phenomena between a liquid and a solid. Students not only build, use, and revise a simple model to describe the observed phenomena, but they're also making observations for use as data to serve as the basis for evidence of an explanation. In this case, the explanation is around how matter is conserved or is still present even when it changes form, in this case from a solid to a liquid, and seems to disappear. This also helps students build an understanding towards the conservation of matter, and that students in the future will be tracking matter flows between states of matter and as they move into other units such as ecosystems, where that matter goes as it's consumed between organisms. All along the way recognizing that the total weight of these substances does not change as it moves from one component or through the system, This video and associated lesson has been produced by the Burlington, Massachusetts Science Center.